Hello everybody, it's Mr. Yosef, and today we're going to learn about transformations and piecewise functions. So there's a lot of different ways to graph functions, but the approach that we choose to take is to graph the parent function, which is the most basic function of a specific type, and then see what transformations were applied to it. So for instance, when we look at number 1, I see a power of 3. So to me, what is a parent function? That would just be x cubed. So our original graph is x cubed, and we did a whole bunch of things in order to get this. Okay, and that's what we're trying to graph. So before we even talk about the transformation and what happened to f of x, let's go ahead and make the table for g of x. So I want you to know that right now, we're making a table for the parent function, which is x cubed. I like to pick some negative and positive numbers if possible. So I'm going to pick -2, -1, 0, 1, 2. And when I substitute -2 into my parent function, that's -2 cubed, which means -2 times -2 times -2, which is -8. I'm not going to do that for the rest. I just wanted to show you that one just so you can see that, first of all, that it's 8 and not 6, because some people do 2 times 3 instead of multiplying it 3 times. And I also wanted to show you that it's negative. So this is our table for our parent function x cubed. So now what we have to do is now go to the original function which we care about, which is f of x, and see the transformations that have applied. So this is a little confusing. So I don't know if you guys remember, but this -2, this means the function is going down 2. I feel like we feel comfortable with that one normally. That means we're going down 2. And the confusing part is this part right here. So what I'm going to first do is I'm going to rewrite this like this. I'm going to factor out a half. And I'm going to explain to you why you have to do that. So I'm going to factor out a half because when you want to know if your function is going left or right, which is normally given to us by this number. So normally if you see a -2 inside of parentheses or square root or absolute value, that means that the graph is going right to. But this one is different because this 1/2 is actually going to affect how much you go left or right. So we have to factor out any coefficient in front of x first in order to know how our function is moving left or right. So what we're going to do is we're going to pull out a half, which is going to give us x, because a half times the x is 1/2 x, and then a half times what gives me -2. Well, that should be -4. So what I want you to see here is I just rewrote what I have. So 1/2 times x is 1/2 x, 1/2 times -4 is -2. So what I have in front of you is exactly the same as the original equation, except this time, this -4, this right here, tells us that we're going right 4. If you looked at this function, it looks like it's right 2, but that's wrong, because when you have a coefficient in front, you have to factor that out first in order to know what that does to your function. So right now, we know that we're going down 2, right 4, and this 1/2 is going to affect our horizontal movement, or our x values. So when we see a half, once again, anytime something affects the x values, we always do the opposite or reciprocal of that. So instead of having a horizontal compression of a half, it's actually going to be a horizontal stretch of 2. So for a lot of us, this is probably a long time ago that we did something like this. So in pre-cal, if you already graphed trigonometric functions, then hopefully this is bringing back memories of what we did before. So what we're going to do now is we're going to look at our 3 transformations, which are horizontal stretch of 2, right 4, and down 2. And we have to ask ourselves, which variables do these transformations affect? So for instance, going down 2, that affects your y values. Going right 4, that affects your x values, and a horizontal stretch of 2 affects your x values. So what I'm going to do here is I'm going to extend my table. And this part can get a little messy, so sorry. And for my y value, since I'm going down 2, I'm just going to write -2 over here just to tell myself that I'm going down 2. So I'm going to take every one of my original y values and I'm going to subtract 2. So instead of a -8, we will have -10. Instead of -1, -3, and so forth. And so those are our new y values. All our y values got shifted down 2. So for our x values, we have the great opportunity to do transformations, but you have to ask yourself, which one do you do first? Do you multiply something first or move right 4? So whenever you're doing transformations, you always multiply first. So we're going to do a horizontal stretch of 2 first. So even though you see a half, when something affects the x value, do the reciprocal of that. So we're first going to multiply by 2. And then whatever we get there, we're then going to add 4 to those answers. So once again, this video is more like a recap of transformations. So if you feel like you're not as comfortable with transformations or you forgot some of these rules, it might be a good idea to kind of review your notes. So here we're going to take all our x values and multiply by 2. And then we're going to add 4 because we're going right 4. And now I'm going to get, let's not get a pink, let's get a green. I'm going to highlight our final coordinate points. So these are the points of our new function. And the cool thing is, if you know what x cubed looks like, then I feel like you have a good idea of whether or not you did this right or wrong. So one thing we should notice is, first of all, our graph is not long enough. So I'm going to stretch this just a little bit longer. And I'm going to write a -9 and a -10. So at 0, I got -10. At 2, I got -3. At 4, I got -2. At 6, I got -1. And then at 8, I got 6. And then I put everything together, and I get this wonderful function. This looks like a cubic function. It looks like it did get stretched out by 2. It definitely looks like it got shifted by 4, and it does look like it got pushed down by 2. So this is how you do this first function. So these are transformations and using parent functions. So I hope that helped for that one. We got one more question to go, and this time we're going to do something called a piecewise function. So what is a piecewise function? It's pretty much when you take different types of functions and you cut them up into different intervals. So here for number 2, sorry, I have no clue what happened there. So for number 2, we have two functions here. We have g of x equals 5, and we have g of x equals negative the absolute value of 2x minus 1. So this is a constant function, and this is an absolute value function. So what's going to happen is we're actually going to graph both of these on the same graph, and these restrictions right here will tell you for what parts you want for each graph. So for instance, the graph of y equals 5, just to graph y equals 5 for you, that's just this right here. This is y equals 5, or g of x equals 5. But do you see how the restriction says that we want x to be less than or equal to 4? So that means that this part right here, I don't care about this part. I don't want this part. I only want the parts that is at x equals 4 or to the left of it. So what I'm going to do is actually I'm going to erase this whole thing. And then I'm going to go to 4. And I'm going to put a dot at 5. And the reason why you want to have a solid dot there is because it says x is less than or equal to 4. So that means that my graph is going to look, let me make that look a little neater. That's exactly how my graph looks like for the first part. So if we read it, it's g of x equals 5. And we are graphing this part of the graph for only x less than or equal to 4, which is what I just did. And we have a solid dot here to show that we are including 4 in this graph. So the next part is a little bit more tricky. We have two options here. We could do what we did on number 1. Like the parent function for this is y equals the absolute value of x. We could make the table for this one, and we could do the transformations like we did on the other one. And I don't mind doing that. But one thing I do want to show you is sometimes that's not always the easiest way. So here it says x has to be greater than or equal to 4. So what I always do is I'm going to take this function, and instead of using transformations, I'm just going to make the table myself. Like I'm going to pick 4, and I'm going to plug in 4. So if I plug in 4, I get negative on the outside and the absolute value of 7. The absolute value of a number just means getting the positive or whatever is inside. So the absolute value of 7 is just 7. And because I have a negative sign on the outside, do you see that I get negative 7? So what I'm going to do is I'm going to go to 4 and I'm going to put an open dot at 7. So the reason why we have an open dot at 7 is because it says x is greater than 4. So that means whatever value is at 4, I don't want to include that in my graph, but I do want to show it because, for instance, like you could pick 4.1, 4.02, 4.03. Everything after 4 is good. So we always plot the value at 4 or whatever value is given to you just to show that that is where it ends or starts. So that's why I'm going to show an open dot there. So now we have our value for 4. So let's go ahead and do 5. So if I do 5, that's going to be 10 minus 1. And I get negative 9. So as you can see, my graph, I'm running out of space a little bit, but just extend it. No big deal. And you see that at 5, it's negative 9, so that's right over here. And you just keep doing this. So if you pick 6, 7, 8, you're going to get negative 11 and negative 13 and negative 15. So pretty much it just keeps going down like this. So what's funny about this and what you should be curious about is, you know that an absolute value function like looks like a V, right? But when you see this part over here, this does not look like a V because once again, everybody, this is just parts of your graph. We restricted the X values, so we're not getting the full picture because we don't care about the X values for this function that are less than 4. So that's why you're only seeing a piece of it. And that's all for this function. You're done. This is your final answer for this one. So I hope you're not confused by me just plugging in the points. That is something that you could always do. Even going back to this original graph of number 1, you could have always picked random x value and substitute them and make your graph. The only problem is when you pick random x values, you don't always get nice numbers. And second of all, you don't always get the full picture of what you're doing. So by doing it the way that we did for number 1, you get the full picture of the graph. But when you do it the way of number 2, you don't always see the full picture. And also we just restricted it because we said x has to be greater than 4. So that's all I have for you. What I challenge you to do for number 2 is try to do the absolute value function the way that we did on the top and see what happens. If you have any questions, please let me know and have a good day.